Hey, John Carlisle here again. We're back from intermission. For our virtual participants, please note our LEEP Connection website contains email addresses and LinkedIn pages for all the fellows and startups pitching today. If you have questions, please use those links to connect directly and learn more about what our startups and fellows are doing. They and LEEP need your help and support if we're going to move these innovations into impact. Now we move to the LEEP node based in Tennessee, Innovation Crossroads. Dan Miller, Innovation Crossroads Director, will start, followed by Oak Ridge National Lab Director Thomas Zachariah, and then followed by pitches from Innovation Crossroads active and alumni fellows.
Hi, I'm Dan Miller, Director of Oak Ridge National Laboratory's Innovation Crossroads program, where we recruit some of the most talented entrepreneurs to work with our world-class resources, such as the Manufacturing Demonstration Facility, the Building Technology Research and Integration Center, and the Center for Nanophase Material Science. We're proud to foster the growth of high-impact startups in the energy and advanced manufacturing spaces, alongside our sponsors, the Department of Energy's Advanced Manufacturing Office and Building Technology Office, the Tennessee Valley Authority, and ORNL. In a few minutes, you'll hear from some of our most recent innovators that have launched startups in energy and advanced manufacturing. You'll also hear from two of our alumni innovators as they continue to grow their businesses to meet some of the world's biggest challenges. But first, I have the honor to introduce one of our region's biggest advocates for entrepreneurship, ORNL Lab Director, Thomas Zachariah.
Let me join my colleagues in welcoming everyone to this first ever LEEP Summit. The national laboratories are indeed home to some of the most powerful scientific capabilities in the world. And the Department of Energy's Lab Embedded Entrepreneurship program allows our best scientists, engineers, and technicians to engage deeply with talented entrepreneurs as they refine and improve their products. Today, we welcome venture funds and potential partners interested in maximizing the potential of these big ideas. We all need one another to solve the energy challenge, address climate change, and build the industries of the future. We need breakthroughs in fundamental science, as well as the private sector partners to take new technology to scale. We also need to expand investment and opportunity beyond a few traditional tech centers. To spur the innovations necessary in the short time available, we need to create opportunities everywhere, in all types of communities across the United States. For Oak Ridge National Laboratory, this means building an innovation hub that expands clean energy and green industries in Tennessee and throughout the Southeast, while attracting the very best talent from around the country. The 26 founders from the first 5 years of our Innovation Crossroads program are playing an important role. They have come to Oak Ridge from coast to coast, not only benefiting from their access to the lab, but bringing transformative ideas and tremendous energy to our community. Most of them are staying here when they complete the program. And some are securing commercial space as they scale up. All along, they're building relationships here in the Oak Ridge corridor that inspire entrepreneurship in the broader community. LEEP has provided a jolt of activity targeted at the most compelling challenges of our time. You'll hear directly from many of these young companies today. Thank you for your interest in these leaders. I hope, like me, you will be inspired by their talent, their commitment, and their passion to change the world.
Hello, everyone. Thanks for tuning in to this year's LEEP Summit. My name is Tommy Gibbons. I'm the co-founder and chief innovation officer at Hempitecture. And at Hempitecture, we make hemp-based building products. What I'm holding here in front of you is a prototype sample of our hemp wool insulation product that is sold around the country. But this isn't just talking about small prototypes. This is talking about something that's going to reach production scale in the United States very, very soon. I'm very excited to share more with you about. So here's the problem. In the United States, we have no natural fiber insulation manufacturers. This is something that's very common in Europe and other sustainably minded parts of the world, but we don't have in our country yet. So our solution and our belief is we deserve better, healthier, lower embodied carbon, high-performing insulation options built and produced domestically inside the United States. So what we're developing at Hempitecture is the lowest embodied carbon, lowest greenhouse gas emissions insulation on the planet. What we do and what our secret ingredient is the hemp fiber, which sequesters an immense amount of carbon during its growth cycle and can be turned into various amounts of products, including high-performing, thermally insulating insulation. Our company, Hempitecture, we develop, manufacture, and distribute these products, and insulation is really just the first window into the building envelope that we feel can be disrupted with lower embodied carbon, more sustainable building products. So let's talk about other insulation products out there and why they aren't as sustainable as a hemp or bio-based insulation product. So if you look at aerogel or spray foam, open cell or closed cell products, they typically have very high R values, which is a measure of thermal conductivity, but what they're lacking is in their embodied carbon footprints. Most of these products are petroleum-based, or in the case of mineral wool, basalt fiber-based, and they take an immense amount of energy to extract from the earth, process into insulation, and ultimately transport into a project. Our product is the opposite. It's a bio-based material that supports rural agricultural farmers, turns their feedstocks into a useful fiber, and takes those fibers into insulation, resulting in a negative embodied carbon footprint. So this solution sounds great, but how long is it going to take to get to America? Well, the good news is we are underway with our manufacturing facility. We've received the international equipment for producing this textile technology, and will be production ready and code compliant in less than 90 days. In fact, 70 days is where we're expected to be producing a code compliant, American-made hemp insulation product, which is very exciting for our country and this industry. So how did we get here? Well, we actually crowdsourced $4.5 million from over 2,000 investors, retail and institutional, to provide the equity to start our manufacturing facility. That may seem like a relatively small amount of capital to create a new insulation product in the United States, but this amount of funding will allow us to go above and beyond what our current sales targets are, what our current production targets are, and get this product into mainstream America. With a little bit more funding, we could regionalize these manufacturing facilities and produce even more. I just noticed the Defense Production Act, for anyone in the DOE or Building Technologies Office who's tuned in, talking about increasing the production of American-made heat pumps and American-made building insulation. Let's not neglect the DOE's decarbonization goals and make sure we're producing installations that can actually lower the embodied carbon footprints of our buildings. Finally, our team is made up of building scientists, ESG professionals, architects, entrepreneurs, and a whole consortium of people who are aware of this product and want to make it a reality in the United States. If you're interested in learning more about how my co-founder and I found this product and decided to commercialize this technology within the United States, log on to hempitecture.com, where you can not only read about our company, you can actually directly order insulation to your next job site. So I want to thank you for listening about our products, our company, and myself. Have a great day and enjoy the other presentations from the other innovators. Thank you.
Hi, my name is Erica Grant. I'm the founder and CEO of Quantum Lock Technologies. We're building the best in security for connected facilities and equipment. There are many different types of facilities on the planet which require access control to gain entry into the facility. Think keycard entry or even mobile access. These systems have significant security weaknesses. In some cases, you can even purchase a $20 device off of Amazon to copy someone's keycard and gain access to the building. These are legacy systems, and the industry is trying to move forward. And they're doing so by creating these cloud-based systems that have detection and monitoring capabilities. They're able to see who's been in the facility and when. This opens up the facility to even more security weaknesses. Physical security has now become a cybersecurity issue. All these new points in communication can be accessed as points of weakness by hackers. That's where Quantum Lock comes in. We create completely random and unpredictable digital keys which can be used on keycards, smartphones, or key fobs. We use something called a quantum random number generator. It's the only device on the planet which is able to do just that. We use these digital keys to protect every single point in communication for an access control system. We also have our connected ledger system, which allows us to see who's been in the facility and when, and monitor and detect all types of access. So we open up access control to this new age of monitoring and detection capability, but we do it so in a much more secure fashion. Through Innovation Crossroads, we have made a lot of traction, and it's a really exciting time for us. At the beginning of the program, we had a proof of concept prototype. Now we have several prototypes and have made significant product development progress. By the end of the summer, we hope to pilot with our first pilot customer. We're aiming to address the utilities market initially and quickly spread into other types of facilities which require keycard entry to gain access to the building. Our phase 2 will actually be to license the hardware side of what we're doing to lock manufacturers that are already building keycard readers. This will allow us to focus on our software, which has our secret sauce, and continue developing security innovations. Quantum Lock is a drop-in tech. Any facility that you can imagine with keycard entry or smart locks can use Quantum Lock. Think manufacturing facilities, hospitals and pharmaceuticals, even eventually hotels and smart homes. Since I started Quantum Lock back in 2018, we've received funding from a variety of sources. Initially, I went out and did pitch competitions and received $75,000 in grant funding from those business plan competitions. Then, by being accepted into the Innovation Crossroads program, we received the funding associated with the Department of Energy. $200,000 worth was able to be used directly for product development. And most recently, we finished our first tranche of our seed round, which was $600,000, with 2 investors here in Knoxville, Tennessee. I'd like to take a moment to thank our board of directors, which includes Randy Boyd, John Bruck, Larry O'Toole, and Peter Fior. I'd also like to thank the Innovation Crossroads team for helping to support Quantum Lock during this Innovation Crossroads program. I'd also like to add that we are currently raising $2 million in equity investment over the next 2 years for Quantum Lock to further product development and to increase sales and scale. Thank you so much for your time, and I look forward to hearing the rest of the pitches.
My name is Joe Fortenbaugh, and I'm the CEO and co-founder of Actinic, and we are printing off-the-shelf resins and solving the material disconnect between 3D printing and industry. So at the moment, there's a big disconnect between the materials that are available for industry and those that are available for 3D printing. So in general, thermoset resins like polyurethanes, silicones, epoxies, and more make up 90% of the polymers that industry uses, whereas 3D printing only has less than 1% of those materials available for 3D printing. So we can print real off-the-shelf resins. So we have resins from Dow, Los Alamos, Smooth-On, NuSil, just for our silicones. And we can take these commercial off-the-shelf resins, reformulate them so we're not changing the chemistry, and we can print them on commercially available hardware. So we're working with O&L on this project, and we're designing the technology to be able to work on the BAM 3D printer at the manufacturing demonstration facility. So the benefit of our technology is that there's no fixed cost and there's a quick turnaround. So for traditional injection molding technologies, it takes months for a product to go from initial workup to the final product in your hand. Whereas with 3D printing, we can turn around a new product in 3 to 5 days, which is 90% faster and has 50% cost savings. For example, we have a grommet from Caterpillar that we're printing that is a low volume but highly needed part for the construction industry. So there's a range of applications for our first material, which is a silicone. So we have seals, gaskets, and grommets, custom fitting respirators for chemical warfare for the Army and medical devices, radiation shielding for the outside of aircraft and aerospace technology, as well as prosthetics and orthopedics for custom medical applications. So Actinic really positions itself against the competitors by being able to print a large number of materials and having materials that are off-the-shelf resins. So most 3D printing materials are very chemically specialized, whereas we can take any commercial off-the-shelf resin that's thermally cured, add our secret sauce to that, and then be able to turn that around and be able to 3D print. So up to this point, we've raised almost $1 million in non-dilutive funding from Penn State, the NSF, Department of Energy, the U.S. Army, and the Oak Ridge National Lab. We've just applied for follow-on grants, SBIR grants from the U.S. Air Force and the NSF, and we're seeking a convertible note for $500,000 in the next year, and then in 2023, we plan to launch our production model. So I'd like to thank my team and advisory board for helping me get to this point. I'd also like to thank Innovation Crossroads and the National Lab for giving me the opportunity to participate in this Innovation Crossroads Fellowship, and I look forward to seeing what the future holds for myself and the other technologies.
Hello, I'm Renee Carter, one of the co-creators and vice president at PixelEXX Systems. At PixelEXX, we're fundamentally changing the way we collect and measure light, designing image sensors to work in complex, uncontrolled environments while collecting more photon information. There are three big pushes in the industry: developing smaller, more energy-efficient image sensors, enhancing image performance, think ultra-high resolution, wide dynamic range, and expanding sensing functionality, such as multispectral imaging. The challenge is that improvement in any one of these areas requires compromise in the others. The underlying problem is a result of how we collect and measure photons, something that hasn't fundamentally changed since the first digital cameras. The signal depends on both the number of photons you can collect and the ability to convert those photons into electrons, quantum efficiency. The challenge is that as we linearly scale the pixel size, the amount of light incident on each sensor reduces quadratically. As a result, for applications that demand greater contrast and clarity or are implemented in light-starved conditions, larger pixels are required to maximize the signal. Collecting more photon information enhances object identification and target discrimination, but challenges the system. Filters decrease photon flux on the detector. The monochrome sensor collects intensity information and has a maximum quantum efficiency of 70%. With the addition of spectral and polarization information, the quantum efficiency plummets to below 20%. Despite these challenges, leading manufacturers are racing to develop submicron pixels. The left side is work by Samsung, modeling 400, 600, and 800 nanometer pixels. They report that while submicron pixels can improve resolution, there is a significant degradation in performance at sizes below 450 nanometers. On the right are absorption profiles from 60, 80, and 100 nanometer Me photosensors. These sensors are designed to induce Me scattering, enabling large absorption cross-sections. The geometry of the pixels determines the peak absorption and the wavelength selectivity. No filters are used. This slide demonstrates the physics enabling the PixelEXX sensor. Light absorption is determined by sensor geometry. The power flow lines in panel 1 show that violet light is strongly absorbed in the middle sensor, but only weakly in the narrow and wider sensors to the left and right. Panel 2 is an electron micrograph showing one step in fabricating these sensors. We are utilizing this physics to transform imaging and sensing. Our core patent was granted last year with broad claims. As you can see in our product roadmap, we've leveraged significant non-dilutive funding. We will have test arrays this summer and expect a beta camera by the end of 2024. We are currently raising $2 million to support development and commercialization efforts. And with that, I'd like to thank you for your time.
Hi, my name is Danielle Cassley, and I'm the founder of Becq, a materials engineering company that participated in the Innovation Crossroads program to develop radiation shielding materials. Becq's shielding technology will improve the safety and economy of the nuclear power industry, and we're very thankful for the support we've received over the past 2 years from Oak Ridge National Laboratory, Tennessee Valley Authority, the National Science Foundation SBIR program, and the Department of Energy Gateway to Accelerated Innovations in Nuclear program. With this support, Becq was able to develop a very unique and very competitive approach to shielding design. Becq is now the only materials company that has high-performance customizable shielding materials. We developed our Beckcrete product line of high-density, pourable gamma absorbers and our BeckShield line of pourable high-temperature neutron shielding. Shielding customizability is very important to us because radiation sources are different across advanced reactor designs, radioactive waste containers, and other nuclear applications. So one of the best things we did was to also build an artificial intelligence platform that can tell us exactly how to modify our materials to design a shield that's perfectly tailored to any nuclear application. Therefore, the next generation of shielding will be designed by putting together the optimal blend of elements instead of force-fitting existing shielding materials such as lead or poly. There are significant benefits with this approach. For example, in a spent nuclear fuel container, our shielding reduced the customer's radiation dose rate by 40% without increasing weight or volume of the shielding. In an advanced reactor application, we customized 2 layers of shielding to provide a 20% reduction in weight and 36% reduction in volume, which will significantly reduce its levelized cost of electricity. What's next for Becq? Well, we're excited to make some big contributions to our reliable and clean nuclear power industry. We have been contracted to design shielding for advanced reactor testing facilities where space and weight constraints impact shielding design. We're also designing shielding for radioisotope generators, advanced reactors, and microreactors. We've supplied specialized radioactive waste containers for research institutions, and we're designing unique auxiliary shielding equipment for several nuclear power plants. Becq is also collaborating with Sandia National Laboratory to work on a DOE, Department of Energy, SBIR program to develop a pourable shielding material for use in the permanent disposal of spent nuclear fuel containers. Repackaging the existing spent fuel containers into permanent containers would cost over $90 billion, but with our pourable shielding materials, we could instead fill all of the existing spent fuel containers in the United States without repackaging to more simply prepare them for permanent disposal at a cost of less than $1 billion. Innovations in radiation shielding, artificial intelligence, and advanced materials are very important to the growing nuclear industry. Nuclear power supports America's leadership in clean energy, it supports our national security and our global competitiveness. Thank you very much to the Department of Energy, Oak Ridge National Laboratory, and Tennessee Valley Authority for supporting Becq through Innovation Crossroads. We had a great experience.
I learned growing up, with many of my family working in the agricultural sector, the power of innovation and how small changes can have big impacts. My grandfather actually started the first recycling program in his small agricultural community in rural Ohio. As soon as I realized the connection between climate change and agriculture, where rising temperatures impact crop growth, it became personal to me to try and solve the climate crisis. I like to think about the what-ifs. What if we take all the carbon dioxide that's being released into the atmosphere and we put it back into sustainable applications? Applications that we use every day, like batteries and tires and coatings. I want to explore all the ways carbon can be utilized so that instead of being a problematic emission that must be offset, it's a feedstock that we can use to power the products of tomorrow. That's why I founded SkyNano, to create a free market solution to carbon pollution. By joining DOE's Innovation Crossroads program at Oak Ridge National Laboratory, I had access to the perfect environment to research and develop my what if. And that's a low-cost, advanced carbon materials solution produced electrochemically to permanently store carbon dioxide in the materials and devices we already use day to day. Innovation Crossroads was a bridge to getting what started as an academic research project at Vanderbilt University on the path to commercialization. SkyNano's technology was patented in May of 2021. And now, every 1 kilogram of carbon powder produced in our materials contains 3.6 kilograms of carbon dioxide captured from pollution. It's a low-cost process, backed by science, built to be scaled up anywhere, utilizing an abundant resource, carbon dioxide. Working with Innovation Crossroads in East Tennessee helped me also realize that I want to put roots down in the greater Knoxville community. I've decided to invest in a community that helped nourish my idea, and I'm currently building new lab space near downtown Knoxville. It's a space that will provide new jobs too, as we continue to grow in staff and products. The what ifs are truly endless.
Hi, I'm Dan Miller, Director of Innovation Crossroads, and I'm here with Mitch Ishmael, co-founder of Active Energy Systems. Mitch, to start off with, can you tell us a little bit about your company?
Yeah. Active Energy is developing advanced low-temperature thermal energy storage for building cooling to help building owners lower their cooling costs, but improve their cooling sustainability and cooling resiliency. Think about it like a big thermal battery where you make a bunch of ice during off-peak hours so that during on-peak, when costs are really expensive, you can just turn your air conditioner off and cool your building with ice. What we were able to do was develop an isotopic coating system that allows ice to just passively shed off cold surfaces as it's being made, which allows us to make ice much more efficiently and with lower cost hardware.
Mitch, can you tell us how did Innovation Crossroads change the trajectory for your company?
It changed it in two really big ways, both on the technical side and on the business side. For the technical side, we came in actually with a completely different technology at the start. And it was through Innovation Crossroads, the access to the expertise at ORNL, the time to be able to play around with some different projects that allowed us to realize that our real innovation was actually on this isotopic technology, not the original technology. So we were able to completely pivot the company and just go down that direction. On the business side, it was really through the Innovation Crossroads team that plugged us into the ecosystem, other entrepreneurs, investors, and because we felt so plugged in, it made us want to stay in the area and continue commercializing the technology.
Speaking of the ecosystem, you're in cohort 1 that came on 5 years ago, and you've done a great job plugging into the ecosystem and leveraging a lot of assets here. How do you think the ecosystem itself has changed since you've been here?
Yeah, I think it's changed by growing. Other accelerators and incubators have founded here. Some of the incubators that we were a part of have grown post Innovation Crossroads. To give you an example, we got an investment from the Tennessee Fund, which is a local fund that puts in a little bit of money, but for really high impact for the company, that allowed us to file on finding a foundational intellectual property that allowed us to continue commercializing the technology, and that's only continued to grow as well. So I think that just that continued trajectory of growth is what has really changed, and it's been really heartening.
Describe that transition from working with Innovation Crossroads at ORNL and coming into a facility like this and continuing to develop. How did you make the transition from kind of developing from lab tech into commercialization?
Yeah, it certainly wasn't all at once. At ORNL, we just had a fraction of a lab space. probably 100 square feet in total. There's a local incubator that we were then able to move into, partially while we were in Innovation Crossroads, but then after they're fully occupied. It was while we're at Innovation Crossroads, we're developing these ideas, writing grants, getting small amounts of funding. That's how we were able to get into the incubator, and now we were just able to continually improve, break off these chunks that we're able to continually improve and improve to get larger and larger amounts of funding until we could end up here in about 5,000 square feet of lab space.
Yeah, this is really impressive. And you've recently raised a seed round. And talk about how to balance still continuing to develop on the technical side, and then do all the things, due diligence, and the other things you need to do to raise a significant amount of money.
Yeah, it's all about the team. The team is what has allowed us to be successful. So, co-founded the company with Lana Twain. He's really done the lion's share of the work on the race, and I've obviously provided support there. And then on the technical development side, when you've got good people, you can just kind of point them at a problem and go. And so I just again kind of support them on that technical side as well. So that's how we've been able to do it.
And it's been really impressive to watch your team grow and as you continue to develop. I guess one last question: what's on the horizon for you and for Acumen System?
Yeah, so we're really excited. We're starting up our first commercial scale system. So this is like serial number 1, first commercial product. We're doing that this summer. And then just on the horizon, we're testing with our OEM partners to allow us to integrate into their supply chain and be able to offer products to the building owners that I mentioned. So yeah, it's a really big scale. It's really neat to see it from the lab, the benchtop, to now we're in a semi-production facility. So as things get bigger, I just keep getting more and more excited. They keep bringing headaches, but it's really fun to know that, yeah, this is going to have a commercial impact.
Well, Mitch, it's been awesome to see you grow, not only your company to grow, but also to grow here in the Oak Ridge, East Tennessee ecosystem. So thanks for having me over, and looking forward to great things to come.
Thank you. Thanks for coming.
Let's do some applause. Fantastic. Hey, congratulations, Dan, Kelly, the whole crew at Innovation Crossroads. We really enjoyed those videos. I know you had to do a big pivot at a very late point in the game with Oak Ridge going into high COVID levels. Everything's pre-recorded. But I know you got a watch party going on. So again, to all of you that are tuning in live to the event there in Tennessee, great job. Really fantastic. Yeah. So again, for the virtual participants, let me remind you that there is a web page that gives you the email addresses and LinkedIn pages for all the fellows and startups that are presenting today. If you have questions, please use those links to connect directly with them to learn more about what they're doing. Again, they and LEEP need your help and support if we're going to move these innovations out into the marketplace. Now we're going to shift from Tennessee to Berkeley, California, and tune in the founding LEEP node, Cyclotron Road. It's my pleasure to introduce Michael Werrell, the director of Lawrence Berkeley National Laboratory.
Hello and welcome to the LEEP Summit. I'm Mike Witherell, director of Lawrence Berkeley National Laboratory. I'm proud that Berkeley Lab is home to Cyclotron Road, the first of the LEEP nodes. In 2014, when Cyclotron Road was born, our goals were simple. By offering talented inventors access to the superb expertise and facilities available at a national lab, we hope to help some of the most promising ideas in energy tech survive through the riskiest stages of R&D. By providing the fellows an income, we also hope to provide access to entrepreneurs who might not already be financially secure enough to put their careers and lives on hold while exploring an unproven technology. In 2015, Cyclotron Road announced its first cohort of 9 inventors, representing a diverse community, each with an idea they felt very committed to. Through our nonprofit partner, Activate, we have since built in professional development and a community of support. To have the greatest possible societal impact, we're investing in our fellows as much as we're investing in their ideas. By 2016, we had a working model, DOE was ready to replicate the program, and here we are, 4 LEEP nodes at our 4 national labs. And because it's a great idea, there will be more in the future. I'm proud to be able to say that since 2015, Cyclotron Road has supported 75 fellows from 56 companies. Those fellows have so far raised more than $400 million in follow-on funding and hired more than 400 employees. Most important, expanding diversity, inclusion, and access continues to be our guide star in encouraging, selecting, and investing in the fellows. It took energy and a creative spirit at DOE, within our lab, and at Activate for Cyclotron Road to get a chance to show what it could do. But the most important achievements are those of the entrepreneurs. They're tackling some of the most critical problems for the benefit of humankind and the planet. I want to congratulate them on their fortitude and spirit of adventure and wish them the speediest possible success. Thank you, and I hope you are enjoying the summit.
Thanks, Mike. Now we will hear from Carol Burns, who is the Deputy Director for Research and the Chief Research Officer at Lawrence Berkeley National Laboratory.
Good afternoon. My name is Carol Burns, and I'm the Deputy Lab Director for Lawrence Berkeley National Laboratory. I want to add my own thanks to the Department of Energy for supporting this really incredible program, in particular the Advanced Manufacturing Office. And I also want to thank all the organizers and sponsors of this summit, including our wonderful local staff. DOE's national laboratories have the ability to accelerate innovation to impact, that is, taking something from basic science in a lab and turning it into something that can really impact people's lives. This is really critical to creating a clean energy economy. Ultimately, a path to impact is often through commercialization of innovative technologies. This is a really important role for the LEEP programs. They are an effective mechanism for accelerating science solutions for the world. The labs have expertise and capabilities to help the LEEP entrepreneurs realize their vision. For example, labs are home to user facilities, which can play an important role in the development, testing, and scaling of innovative technologies. Many of our Cyclotron Road Fellows have benefited not just from the expertise of mentors at Berkeley Lab, they've also accessed the Molecular Foundry, the Advanced Light Source, NERSC, or capabilities resident in other centers and facilities supported by many parts of the Department of Energy. Of the 62 companies we've supported at Cyclotron Road so far, we've had at least 20 teams with Molecular Foundry user agreements with 66 Foundry user projects, 10 bioscience teams who have accessed the capabilities of the Joint Bioenergy Institute or the Advanced Biofuels and Bioproducts Process Development Unit. Cyclotron Road companies have also accessed other laboratory facilities, including the Center for X-ray Optics, the Joint Center for Artificial Photosynthesis, as well as Cal testbed facilities for clean energy technologies and other facilities funded by the state of California, and Flex Lab for testing energy efficient building and grid technologies. Our lab scientists and our facilities and capabilities get so much in return from engagement with the Cyclotron Road entrepreneurs. It's truly a symbiotic relationship. In the end, the success of Cyclotron Road alumni companies is very inspiring. I'm grateful that these entrepreneurs have dedicated their careers to helping us realize a cleaner, brighter future. I really love the secretary's term, clean energy change agents. And I really look forward to more exciting news from cohorts yet to come. So welcome.
We're good. Thank you, Carol. And thank you, Mike, for your thoughtful remarks. My name is Tom Kirchstetter. I'm the interim director for the Cyclotron Road program here at Berkeley Lab. And it is really an honor for me to be able to introduce to you 6 amazing entrepreneurs. For the summit, Cyclotron Road is showcasing entrepreneurs at different stages of their journey. Speaking of that journey, as Carol Burns just noted, the fellowship offers our entrepreneurs access to national laboratory resources, which include amazing facilities, but also amazing people. And that comes at a critical point in this journey for our fellows as they are advancing their technologies to viable market products. And as really wonderful as that opportunity is, we know that it's actually not enough because entrepreneurship, hard tech entrepreneurship, well, it's hard and it requires more than that. It also requires business acumen. It also requires keen industry insight. So to position Cyclotron Road Fellows for broad societal impact, Berkeley Lab partners with Activate. Activate brings to this program world-class entrepreneurial education, access to funders, access to industry experts, and high-touch personal mentorship for the full 2 years of the program to support our fellows as they develop as leaders, as they mature their ideas, and as they learn what it takes to build a viable and scalable business. So I'm going to introduce the first few presenters from Cyclotron Road, who are going to tell us about their technology and share with us a little bit about their journey. So the first three entrepreneurs are from our graduating 2020 cohort. First up is Amanda Stiles of Umaro Foods. Umaro Foods is producing and developing the most sustainable protein source on the planet. Following Amanda, you'll be hearing from Jay Schwalbe of Nitricity. Nitricity is fixing the way that we fix nitrogen. And following Jay, you'll hear from Noemi Bonessimo. Noemi is of Metaseismic, and Metaseismic is creating sustainable metamaterials to dampen impact and vibration. So please welcome to the stage Amanda Stiles. And following Amanda's presentation, you'll hear pre-recorded messages from both Jay and Noemi.
Thank you, Tom, for that great introduction. So I'm Amanda Stiles, and I'm really excited to introduce you today to Umaro Foods. So at Umaro Foods, we are developing a new alternative protein from a place you might not have expected, from the ocean. So to start off, it's not news to anyone here listening today that one of the easiest ways you can make an impact on climate change is by what you choose to eat. The higher up on the food chain that you eat, the higher the carbon emissions needed for its production. Especially, I'm talking about protein. So protein globally, livestock production creates about 15% of global emissions. Eating lower on the food chain can help diminish that. And livestock production also contributes to deforestation, water pollution, and the unethical treatment of animals. People are moving to plant-based diets, and this is reflected in the market. So in the next decade, an exponential growth is expected in alternative proteins. But to do this, we need to protect our precious resources. So as the climate warms, we need to protect both land and fresh water. Right now, where we get our protein from are these three places: from land, from animals, which we already know result in climate emissions, from land plants that are used in the majority for feeding these land animals, and from ocean plants, which we know we're overfishing our oceans. But ocean plants are a completely untapped white space. The ocean is the most productive, lowest cost source for producing protein. It covers more than 71% of the Earth's surface. More than 80% of the reactive nitrogen in the world is in the ocean, the building block of protein. And seaweed has a very high photosynthetic efficiency. And it's surprisingly high in protein, up to 40% by biomass. It's also a sustainable crop, supported by the Nature Conservancy and the World Wildlife Fund. This in the future is where we'll cultivate our protein. So at Umaro, we're concentrating protein from seaweed. We're separating the protein from the carbohydrates that are in the seaweed, starting from, in this example, a 20% protein seaweed and resulting in a 65% protein concentrate. Our resulting protein powder is 97% digestible, full of essential amino acids, and it serves as a functional heme replacement. We're pioneers in this space, developing a protein powder at pilot scale using commercially available food equipment. And soon we're gearing up to produce it at commercial scale next. But none of that matters if it doesn't taste good. So that's why we're producing our crispy, crunchy, plant-based bacon. So this isn't a picture of real bacon. This is our Umaro plant-based bacon made with both our red seaweed protein and the special gels found in seaweed to help encapsulate the fat. Bacon is a $60 billion market. And if you'd like to try it, we're at these 3 restaurants in San Francisco, Nashville, and New York. So please stay tuned as we expand to other restaurants and into new products. So a quick shout out to the team. Our CEO, Beth Zotter, our Director of Business Development, Royal Sayowitz, and our lead scientist, Tim Arapov. And of course, a thank you to our sponsors. We couldn't have gotten started on the science side of this without the support of Cyclotron Road, the Activate Fellowship, the Good Food Institute, and RPE. So thanks so much.
Hello, I'm Jay Schwalbe, one of the co-founders and chief science officer of Nitricity. And before I'd start, I'd just like to thank Activate, Cyclotron Road, and the AMO for this opportunity to be involved in the Activate Fellowship. It really helped Josh, Nico, and myself as we really got our legs under us in about 2020 for this company that we spun up starting in 2018. It's been a really awesome fellowship that's given us a lot of support and really helped us get our bearings in the entrepreneurial space. So what do? So we are fixing the way that we fix nitrogen. Now, you might not have thought about fertilizer as necessarily the most trendy or exciting startup topic, but I hope I can change your mind a little bit. And so I'm going to start by showing you kind of what's wrong with how we do it today. So today, fertilizer, which is of course used to feed the world, they estimated about only 50% of us would be here today if it weren't for artificial fertilizer, is produced in centralized Haber-Bosch facilities. And so the problem starts with the production. Haber-Bosch process takes in natural gas or coal, gasifies that to make hydrogen, and then uses that hydrogen to make ammonia. Now, of course, in the steam methane reforming process, there's a lot of CO2 is given off. And even though nitrogen fertilizer, of course, has no carbon in it necessarily, the process accounts for about 1% of global CO2 equivalent emissions. The next problem comes in the distribution. Because these facilities are such high pressure and such high temperature, they must be very large. And this leads to there only being a few hundred of them in the world. Now, when things are flowing well, this isn't necessarily a problem, at least in much of the developed world. However, given the tumult of the last few years, it's easy to see that one ship gets stuck in the Suez Canal, a freak frost in Texas at the wrong time, or on a much more serious note, international conflict can easily disrupt the flow of fertilizer and natural gas. And finally, in the application of fertilizer, because of these long supply chains, the fertilizers that are sent to the farmer ultimately are usually chosen for how well they ship, not necessarily how well they work with the soil. So today, it's largely ammonia or urea that are shipped around. And the problem with these fertilizers is that due to the microbial pathways they have to go through before the nitrogen is absorbed by plants, about 1 to 4% of the nitrogen is lost to the atmosphere as nitrous oxide. And this is no laughing matter, as nitrous oxide is 200 to 300 times more potent as a greenhouse gas than CO2. So even that small loss fraction leads to about 5 to 6% of global CO2 equivalent emissions. And this is an area that's being increasingly targeted by regulations in Europe, as well as the US. And so why is the time now to start looking at solving these problems? Well, there's still going to be the necessity. Today, again, the Haber-Bosch process accounts for about half of all fixed nitrogen on the planet. So that means legumes, natural nitrogen fixation is about half of what there is out there, and the other half is humanity. We account for half of the nitrogen cycle, which is truly insane, and we need to do even more. By 2050, the UN estimates that the need for food will double due to the growing population. And today we're already struggling to meet this demand due to tumultuous global events. So you can see global fertilizer prices have skyrocketed. This was a number that back in my PhD, when I was working on different technologies to make ammonia, you couldn't have set a number low enough to get the price right for anhydrous ammonia. And yet today, it's going up 5-6 times. It keeps going up. And this is a pain point for farmers and really shows some of the weaknesses in our current system. Now, finally, there's the good news. The good news is that due to an increasing awareness in the private and public sector of the challenges of global warming, as well as the need to transition to a more sustainable economy, there's a great opportunity to build new industry. And part of this is the fact of the rise of sustainable and cheaper electricity. And so we look to leverage that. So how does Nitricity bring it all together and solve these problems? Easy. We capture lightning in a bottle. That's being a little bit facetious, but it is essentially what we do. So we use a plasma-based process, much like lightning, to oxidize nitrogen in the atmosphere. And then we capture those products in water to make nitrate-based fertilizers. So this is an electrified process, so we lose the need for coal or natural gas. While a plasma has very intense conditions inside of it, externally it's actually fairly benign. So you don't need a high-pressure reactor like the Haber-Bosch process, so you can do this in a more distributed fashion. So this will enable fertilizer production on the co-op level or the large farm level, rather than the truly globalized versions that we see today. And finally, because we produce nitrate-based fertilizers, when used in the right way and in the right soils, these can actually have a dramatic reduction in the N2O losses. So we see kind of a way to attack the production, distribution, and application problems with fertilizer. And if that sounds exciting to you, which I hope it does, please keep a lookout through all of Nitricity's channels, so on LinkedIn, on our webpage, because we'll have a hiring push soon. So please stay tuned, and thank you very much for listening.
My name is Navi Bonesio, and I'm the founder of MetaSeismic. MetaSeismic is creating novel metamaterials to provide ultra-compact and sustainable solutions for the protection against impacts and vibration. Anything we design needs to resist impacts and vibration in buildings, equipment, or electronics. Even a small vibration can be highly amplified and cause damages and failure. For protection, we either use hardening cages or we surround objects with a large amount of isolation material, like foams. We can prevent failure most of the times, but neither of these solutions is currently enough to completely prevent damages. And they have a huge environmental impact. They are carbon intensive, wasteful, and expensive. Our infrastructure in seismic areas requires large amount of carbon-intensive reinforcement to withstand dynamic loads. Buildings need 30% more reinforcing steel and cost 40% more. Similar carbon and cost-intensive reinforcement is needed for IT equipment and batteries. And for shipping, large volumes of protective materials are currently used. 100,000 tons of such materials are landfilled every day, and foams make up for 30% of landfill's volume. MetaSeismic is creating a solution to avoid these carbon-intensive and polluting materials, while providing the highest level of protection. With this aim, MetaSeismic has a new approach. We have developed a novel class of metamaterials that protect not by volume, like a current solution, but rather through the small mechanisms these materials have inside. Our artificial intelligence algorithm can design ultra-compact, low-carbon, and high-performance metamaterials for solutions across all industries. Our algorithm uses the vibration as an input to create a metamaterial that is exactly what is needed to fully protect an object from damage and failure. The algorithm uses a wide database of material properties, manufacturing methods, and internal mechanisms to make the protective metamaterial layer thinner than anything else on the market. This video shows how a thin layer of MetaSeismic filters out the vibration from the glass on the left. Imagine how the same metamaterial can protect an electronic device during shipping. An example of metaseismic application is packaging. While protective foams require a large volume to absorb shocks, a better protection can be provided by a much thinner layer of dynamic metamaterial. This compressive test shows that the thinner layer of metaseismic can replicate the stress-strain cycle behavior of a large foam pad within the typical stress range for cushioning applications. By modifying the internal architecture, the algorithm improves the protective performance of traditional foam by reducing cycling degradation 10 times, doubling the energy dissipation, and reducing permanent deformation resulting from shocks by 15 times. And the life cycle assessment of metaseismic shows a 10 times reduction in greenhouse gas emissions compared with the foam used to ship electronics. The analysis considers the overseas shipment of server racks and assumes, based on experimental data, that metaseismic can be reused a minimum of 10 times and can save 10% of cargo space in ships due to its reduced volume. The assessment also shows lower impacts on human health, ecosystems, and resources when compared with the state-of-art foams. Our platform has applications across high-impact markets, from the packaging industry to building, aerospace, and automotive sectors. During the program, the support from Cyclotron Road and Activate was fundamental, not only to validate the technology, but also to start the pilots with Tier 1 electronic companies to commercialize the technology. And the next pilots will be in the aerospace and automotive industries. Thank you.
Thank you, Amanda, Jay, and Noemi. A shout out to Jay. I think that was the first joke I heard of this summit. Nitrous oxide emissions are not a laughing matter. He'll be here all week. Our next two presenters are from our 2021 cohort, which means they're just now beginning to enter into the second year of their fellowship. We'll hear first from Pete Christensen of Flow Materials. Flow Materials is developing infinitely recyclable polymers to enable circular design. And following Pete, we're going to hear from Aaron Hall of Entropic Materials, making truly compostable plastics for a circular bioeconomy. So let's welcome Pete to the stage.
Great, thanks Tom, and thanks for the local team here for putting this event together. This has been fantastic so far. I'm Pete Christensen, CEO and co-founder of Flow Materials. And at Flow Materials, we believe that design for the circular economy, design for an end of a product's life, is the future of all products. However, the available portfolio of infinitely recyclable materials is significantly limiting to product design. Now, this is particularly true of plastics. Now, plastics are great materials. They're inexpensive, they're lightweight, and they can be formulated to exhibit a very broad range of functional, mechanical, and aesthetic properties. However, more than a quarter of all plastics and polymers that we produce are currently not recyclable. I'm referring to a class of materials called thermosets. Thermosets can be found in things like composites, rubbers, foams. Tires are made of thermosets. And owing to their three-dimensional connectivity of the chemical building blocks, these materials cannot be melted and therefore are very difficult to recycle. At Flow Materials, we're directly solving this problem of network polymer recyclability by introducing a new way to both manufacture and recycle these types of materials. Our core intellectual property is shown on the left here, where we've invented a new bond that can be disassembled at the end of life, allowing us to recover the building blocks to make these materials again. And now when applied to the synthesis of materials, we can use this reversible bond to make these network polymers. These network polymers can, of course, be formulated by adding plasticizers, dyes, flame retardants, all the things that we would need to add to make functional products. And the secret sauce here, what's really magical about this system, is at the end of life, these PDKs can be disassembled to give us back the chemical building blocks to remanufacture these materials with lossless quality. In addition, we can remove all of these additives that we put into the material at the end of life. PDKs are a platform technology. So we have the ability to formulate these materials to exhibit a very, very wide range of both mechanical and aesthetic properties. They can be synthesized from a wide range of commonly and inexpensively available feedstocks. We also see the PDK chemistry as a way to unlock chemical circularity in a wide range of currently available polymer systems. And so if you or anyone you know work with either of these feedstocks or any of these polymer outputs, we would love to speak with you. Through Energy I-Core, we tried to identify where to start. And so we have this platform technology. What should we make first to demonstrate that we can both manufacture with these materials and also demonstrate that we can recycle? And so we wanted a product that generated a lot of waste quickly, something that had high material costs and had high retail margins and also low material requirements. We wanted to, as we're scaling this material out of the lab, work directly with manufacturers and put a product into customers' hands very quickly. And also in the style of Doc Brown from Back to the Future, if you're going to build a time machine, do it with style. That resonates very strongly with me and my team. And so combining all of these selection criteria, we settled on making eyewear as our first product. And I'm very happy to announce and introduce to you the first pair of Flow Materials eyewear in my hands and now on my face. Very exciting. So while many of you probably have multiple pairs of eyewear, spectacles and sunglasses, what you may not know is that the manufacture of these products generates a huge amount of waste. And so this slide shows a sheet of Flow Materials PDK going through, dropping directly into one of our manufacturing partners' manufacturing process. And so you start with a sheet, and you subtractively manufacture away about 90% of the material that goes into this product. And so the output from this machining process is shown on the right, where a very small quantity of material actually ends up in the final product. All of these bits in the middle and this material on the outside of the frame is discarded as waste. In aggregate, this results in about 25 million kilograms of material for these products alone thrown away every year, which is about $750 million in materials inefficiency. So we think we can absorb quite a bit of this by bringing our materials directly to this market. So as we scale into the eyewear industry and beyond, our vision as a company is to be both the beginning and end of the material's life. And so we identified through I-Core that it's not enough to bring new material solutions to market. You also have to help people close the loop in these materials' life cycles. And so we want to offer a very broad portfolio of these infinitely recyclable materials while also providing recycling as a service. We're a small but growing team. I'm very excited to be working with my partner in crime, Kezi Chang. Teamwork makes the dream work, and I can't think of a better person to be working on tough problems with. I'd also like to thank the Department of Energy Advanced Manufacturing Office for sponsoring us in Cyclotron Road. And thank you very much for being here and for listening. Happy to connect after the event. Thanks so much.
Hello, everyone. I'm Aaron Hall, founder and CEO of Entropic Materials. And today I'm going to tell you about our work commercializing truly compostable plastic for the circular bioeconomy. Now, plastics are everywhere, thanks to their amazing properties, their easy manufacturing, and their low cost. Unfortunately, this ubiquity is creating an environmental disaster, polluting our land, water, and increasingly our bodies and those of our animal friends, thanks to microplastics. And that's because they're not trivial to dispose of. I'm sure everyone here has had the experience of standing in front of a set of bins, wondering, where in the world do I put this? And just because it has some chasing arrows is no guarantee that a product can actually and will be recycled. And who knows what to make of all the eco-conscious signaling that's out there. There's a lot of greenwashing. We need something that's both easier and better. And I believe that true compostability is key to achieving that future sustainable plastics economy. And the market agrees. We're seeing an increasing number of compostable plastic products hit the shelves, and the market is already in the billions of dollars and is growing fast. Through participation in the NSF I-Core, I interviewed over 100 stakeholders in this space. And through those conversations, learned that these products that are hitting the shelves don't always deliver on their breakdown promise. The reality is that the composters are velocity-driven businesses, and their 40 to 60-day turnover times are just a lot faster than the 80 to 180 or even more days needed for breakdown of these products. Faster degradation is key. Now, the reason the current degradation is slow is because in nature, plastics degrade from the outside in. Microbes in the soil use enzymes, represented here by these green circles, to chop randomly at the surface, leading to inefficient breakdown and the formation of microplastics. Our approach is to eliminate that middleman and embed the enzymes themselves directly inside the plastics. These materials can then uniformly degrade from the inside out. Further, this happens under a unique mechanism where each polymer chain is degraded monomer by monomer from the end, yielding only small molecules, no microplastics. And this isn't just theory. We've shown that the approach works. On the left, we have enzyme-embedded fibers that were extruded at industrially relevant temperatures that rapidly and completely degrade in simple warm water baths. Further, we can actually recapture and repolymerize the small molecules that this produces, leading to an awesome circular economy approach. And on the right, we show enzyme-embedded polymer films degrading in simulated compost conditions. We get immense degradation in days, not months or years. We have a wonderful set of go-to-market potential that we are actively exploring right now. Our approach provides value across the entire value chain, expanding the design space for products and eliminating concerns around degradability. And this is all enabled by our nanoprotectant platform, which lets us stabilize enzymes outside of cells, within chemical solvents and materials. I like to think of them as PPE for proteins. They keep them safe while they do the hard work. We're living through a biotech revolution, which is playing a key role in our move away from petroleum. Enzymes are the workhorses of this shift, and our stabilization platform unlocks and expands that market. Last month, I hired my first employee, Jolene Matson. As head of process engineering, she's leading our move from bench up to the kilo scale, and I'm actively hiring for chemists, engineers, and scientists. I also have wonderful advisory support from Ting Xu, my academic advisor where the work started, as well as numerous industry veterans. I'd like to thank DOE AMO for sponsoring my participation here in Cyclotron Road and the Activate community for all the mentoring and support. The NSF for that support in the ICOR programs, UC Berkeley and all the others who've been a wonderful bolster to our product and our technology. My contact is here, Aaron Hall at entropicmaterials.com, and I'd love to chat with you further. Thank you all for the space and time.
Thank you, Pete, and thank you, Aaron. So we have one more presenter, one more speaker representing Cyclotron Road, and he is an alumni of Cyclotron Road and Activate from our 2016 cohort. He's the CEO and co-founder of Cuberg. Cuberg is powering the future of mobility. So please give a warm welcome for Richard Wang.
Good afternoon. My name is Richard Wang, and I am the founder and CEO at Cuberg, where we are commercializing next-generation lithium metal battery technology to power the future of electric mobility and the most demanding applications out there, from electric aviation to long-haul trucking to maritime transportation. But this is a story not only about Cuberg, but really about how Cuberg is a true example of successful government policy and public-private partnerships at work through Cyclotron Road and through the Department of Energy. My journey in clean energy started actually back in 2009 when I was still an undergrad at Caltech in Southern California. And we participated in the Department of Energy's solar decathlon competition, where 20 university teams fought it out to make the most advanced net zero solar powered houses. And this really inspired me to launch a career in clean energy. I then ended up at Stanford University, and this comic you see, which is actually something we put together for our Cyclotron Road application from 2015, actually shows a little of our journey, starting at Stanford, where my PhD work was really funded by the Vehicle Technologies Office to a large extent, and where I spent lots of my time at the national labs, including SLAG, Argonne, Oak Ridge, and Lawrence Berkeley Lab. And that journey ultimately led us to Cyclotron Road, which has been foundational to our success as a company. If you zoom in on the bottom right panel of this cartoon, you'll see, I think, the most interesting panel on this slide, which really describes our company journey very succinctly, which is that Cyclotron Road has been instrumental in the success of our company and in guiding us along a journey that is incredibly difficult and perilous for any startup. Any startup is challenging to run. Battery startups are particularly incredibly difficult to run successfully. And with the support of the Department of Energy throughout our lifetime as a company, we've made it to the top of that mountain, or at least the first mountain that we're climbing, through to our successful acquisition and exit early last year. We're now well on our way to developing most of the things you see at the top of that mountain, including electric planes, drones powered by our batteries, and essentially flying cars. The phone flying around in there, maybe we're still a little further away from that one, but well on our way towards achieving our original vision with Cuber. And so with our acquisition, we are now part of a mother company called Northvolt. This is a leading European manufacturer of the world's greenest and most advanced battery technology on the planet. And Northvolt is a company, while a startup, that's incredibly well resourced and funded. They've been around about 6 years. They have 3,000 employees. And the combination truly of Northvolt with their resources and manufacturing scale and supply chain sophistication, combined with the advanced technology and nimbleness of Cuber as a technology startup, it is truly unique in the battery industry. And Northvolt is not only building out gigafactories, but they're doing it in the right way, with the most sustainable manufacturing practices powered by clean energy and highly sophisticated and efficient supply chains, really focused on localized supply chains and domestic sources of critical materials. And with Northvolt, we're really building out not only a technology, but an entire battery industry in Europe and in the United States, focused on localizing critical materials from mining through to materials processing to cell and module and systems manufacturing. And I'm excited to announce today that we are well on our way towards developing not only a battery cell, but the world's most advanced battery module and system built on the most advanced aviation manufacturing line in the world, right here in the United States. This will directly lead to the creation of many hundreds of jobs, billions of dollars in economic impact in the US, and really cement the US's early lead in driving forward the next generation of aviation. The battery is as critical to the success of the electric aviation era as the jet engine was in enabling the success of the jet airline era. And together with the continued support of the Department of Energy and through visionary acts like the battery infrastructure law that was recently passed, we believe we can work together to truly make this future vision of battery-powered flight a reality for everyone. Thank you for your support.
Thank you, Richard, and thank you to all the speakers representing Cyclotron Road at the summit. I am really inspired by what you do. Congratulations on all your achievements so far, and we're looking forward to what you do moving forward. This ends Cyclotron Road's presentation for the summit, but please do stick around, of course, for the Inclusive Innovation Panel, which will be moderated by DOE's own Shalonda Baker. So I want to thank all of you for being in the audience. I want to thank all of you for tuning in out there. And I'm glad to turn the mic back over to John Carlisle in Chicago.
Fantastic, Tom. Congrats to the whole Cyclotron Road team, Tom, Melanie, everybody. Wonderful, wonderful segment. So we're going to take an intermission, and we're going to start back at 4 p.m. sharp Central Time. That's about 4 to 5 minutes, so we'll see you in 4 minutes or so.